Okay, so welcome back to my channel. For today's video, we'll talk about the logarithmic function formula for integration. Okay, so before we begin, I trust by now you already have a solid concept on what is integration, because on the first video that I give you, we already have defined what is integration, and we defined it as the inverse operation of differentiation. Okay, so therefore, if we take the differential of ln u, yan. So the result is equal to derivative of u over u. Now, applying the concept of integration, we can therefore say that the integral of du over u, it's here, is therefore equal to ln u. Because as we have defined that integration is just the inverse operation of differentiation. So we therefore can do this. Therefore, the integral of du over u is actually equal to ln u. Okay? So this will be the logarithmic function formula for integration. So the integral of du over u is actually equal to ln u. Yun. Okay, let's have several examples. I have 3 examples here. Let's start with, we have here the integral of a squared dA all over a cubed minus 2. Now, you might think that, what if we apply the power formula here? Okay, so if we apply the power formula here, obviously you cannot use a squared as your n, as your u, because if you use this factor as your u, you will have your n is equal to 2 and your u is equal to a, your du is equal to dA. Diba? You will be, this quantity right here will be left out. So you cannot do that. Now, what if we use the denominator? Okay, so this one, if this is, diba, we can write this as the integral of a cubed minus 2 raised to negative 1, right? A squared dA. Yan. So we can do that. And if we apply the power formula, you might think your n is equal to negative 1 and your u is equal to a cubed minus 2. And of course, your du is 3a squared dA. Yan. Your a squared dA can be found on the function, on the original given function. So let's just try. Okay, so if we apply the left side of the power formula, you will get the integral of course, your u, your a cube, your a cube minus 2 raised to n, which is negative 1, and your du is 3a squared dA. And you have to introduce correction factor, which is 1/3, because of this 3 right here. You need to see to it that your function is equal to the original given function. So you have to introduce the correction factor 1/3 so that your 3 here will be neutralized, for the lack of word. Okay, so the next step now is to apply the right side of the power formula, and that is, of course, you have to copy your 1/3 and u raised to n plus 1, right? Your u is a cubed minus 2 raised to n plus 1. Your n is negative 1 plus 1. So you will have 0 as the result. So we'll have here, let me erase that one. Negative kasi yung n mo, negative 1. So your negative 1 plus 1, that would be equal to 0. So you will have here over 0 also. And take note, division of 0 is not allowed, diba? It's undefined. So that's the problem right there if your n is equal to negative 1. Okay? So to answer the question, because someone asked during our first synchronous meeting, diba? Yung first synchronous meeting natin, somebody asked if we can apply the power formula if your n is equal to negative 1. And the answer to that question is no, you cannot apply the power formula if your n is equal to negative 1, because you'll end up dividing your u with 0, and division of 0 is not allowed because it would be undefined. So yun. So instead of using the power formula, you can resort to what we call now yung logarithmic function formula for integration. So yan. So we'll erase this one because, as I have said, we cannot use the power formula. Yan. Okay. So we'll use the logarithmic formula for integration. Okay. So you have to identify the value of u. And your u is, of course, your u is a cubed minus 2. And of course, your du will be 3a squared dA. Okay, so your a squared dA can be found on the original given function. Diba? So you can proceed. Okay, so applying the left side of the formula, it's right here. Integral of du over u. So we'll get the integral of your du is 3a squared dA all over your u is, let me erase that one. Your u is a cubed minus 2. Now, obviously, this function right here is not exactly the same with the original given function. So you have to introduce a correction factor pa, which is equal to 1/3. So that because of your 3 here, wala namang 3 sa original given function. That's why you have to introduce the correction factor 1/3. And the next step is to apply the right side of the logarithmic function formula. Your that is equal daw to ln u. Ay, by the way, may plus c pala dito pa. Plus c. Don't forget that. Okay, so ln u plus c. Yan. Okay, so this will be equal to 1/3. Of course, ln u, your ln and your u is, it's right here, your u. A cubed minus 2. Yan. Of course, don't forget the plus c. So this will be your final answer. So this is the final answer. 1/3 ln a cubed minus 2 plus c. Yan. That's the final answer. Now let's try to check our answer if that's really the answer. Let's try to check. So we'll have the differential of our final answer, which is 1/3 ln a cubed minus 2, of course, plus c. Yan. So this will be, we have here 1/3 differential of ln a cubed minus 2. So that would be the differential of a cubed minus 2 over a cubed minus 2. Yan. Differential of c is 0, so I'll not put it there na. So this is 1/3 differential of a cubed minus 2. That would be 3a squared dA. Yan, all over a cubed minus 2. Yan, so your 3 right here, it can be cancelled out. So you'll be left with a squared dA all over a cubed minus 2. Yan, so this one right here is, as you can see, that's exactly the same with the original given function. So therefore, our answer is correct, and that is 1/3 ln a cubed minus 2 plus c. Okay. Let's have another example. I have your example number 2. So we have the integral of y cubed plus 4y all over y squared minus 1 dy. Yan. Y cubed plus 4y all over y squared minus 1 dy. Okay, so actually, if you are integrating a function, the technique is, parang yung mga technique kasi is nabibuild up yan as you try to answer more and more integral function. Okay, so if you are just starting, okay, mag-start ka sa pinakauna. Okay, so you are given a function. Oh, i-try mo muna yung the power formula. If the power formula doesn't work, then that's the time you go to the next formula. And as you try to evaluate more and more function, nabibuild kasi yan yung yung intuition. Parang sa unang pagkita mo pa lang sa sa function, dahil nga marami ka nang na-solve, you know what to do na. You know what formula to use. Okay? So if nag-start ka pa lang, you try to trial and error ba? You try power formula first, then if it doesn't work, you go to the next formula. Okay, so that's exactly what we will do here. Okay, so if you try the power formula, obviously you cannot use y squared minus 1 as your u because your n will be equal to -1. And as I have explained earlier, you cannot use the power formula if your n is equal to -1. So since there are only two factors, right? This one and this one. So the only available factor to be used in power formula is y cubed plus 4y. So, but if you use that as your u, diba, your n would be 1. If you use this one as your u will be y cubed plus 4y, and your du will be 3y squared plus 4 dy. Yan. But your y squared plus 4 dy cannot be found on the original given function. Diba? It cannot be found here. Okay? So therefore, that's the time you can say that you cannot use the power formula. So that's the time you will resort to another formula, and we will now use the logarithmic function formula for integration. Let us try. Try lang. Okay, so obviously you cannot use your u because you cannot use u as your y cubed plus 4y because yun nga, yung du niya, yung differential of u, cannot be found on the function. So you cannot do that. How about if we use the denominator as your value for u? Your u will be y squared minus 1. So your du will be 2y dy, right? 2y dy cannot also be found on the original given function. So, yun. So, hindi pwede yung power formula, hindi rin pwede yung logarithmic formula. Okay, so what will we do? Okay, so kung di rin pwede ang duduhang formula, okay, we try to manipulate the function. We try to apply our knowledge in algebra. Okay, as you can see, the numerator is of higher degree than the denominator. So what we have to do is to perform the operation. Divide. We have to divide. Okay, so if we divide, let me divide this one. So we'll have y cubed plus dapat may y squared. So 0y squared plus 4y plus 0 divided by, I'm using the long division, y squared minus 1. So y cubed divided by y squared, that's y. Y times y squared, that's y cubed. Y times negative 1, that's negative y. So I'll put it here, negative y. Then subtract, this is 0, 0. This is 4 minus negative y, that would be positive 5y plus 0. So yung 5y yung remainder. Or you can write the quotient as y plus 5y all over y squared minus 1. Yan. So this is the quotient. Therefore, this is the original function. And if we perform the division here, the quotient will be y plus 5y all over y squared minus 1. So therefore, we can say that this function is actually equal to the integral of y plus 5y over y squared minus 1 dy. Yan. Okay. So to perform the integration, pwede nyo mahirap pagbulagon. So you will have the integral of y dy plus the integral of 5y dy all over y squared minus 1. Yan. So on the first term, we will use the power formula, and on the second term, we'll use the logarithmic function formula for integration. Okay, so we'll have here your n here is equal to 1, your u is equal to y, and your du will be equal to dy. And right here naman, you can write your 5 here. So I'll put it here 5. Okay, let me erase that one. I will erase 5 and I'll put it outside of the integral sign. I'll put it here. Yan. So this time your u will be y squared minus 1, and your du will be 2y dy. Yan. So we'll now apply the left side of each formula, the power formula and the logarithmic function formula. So this will be equal to u raised to n, y raised to n dy, plus, of course, you have to copy 5, the integral of du over u. So you have your 2y dy over y squared minus 1. Now you have here 2, and then on the original function, walang 2 dito, di ba? So you have to introduce a correction factor. You have to multiply this by 1/2. Yan. So 1/2 times 2, that would be, it will cancel out. So parang the same lang siya, yung value niya the same to the original given function. Yan. So after that, you will now apply the right side of the power formula and the logarithmic formula. So this will be y squared over 2 plus 5 times 1/2, that would be 5 halves. Integral of this one, that would be ln u. Your u is y squared minus 1. Of course, don't forget the plus c. Yeah, so this will be our final answer. Yeah, so that would be our final answer. Now let's try to check if that answer is really correct. Let's try to check. So you have to differentiate our answer, and that is y squared over 2 plus 5 halves. You have your ln y squared minus 1. Of course, plus c. Bakit 0? This is plus c, ha? Yan. This will be equal to differential of y squared over 2, that would be 1/2 times 2y dy, plus we have your 5 halves ln of y squared minus 1, that would be 2y dy all over y squared minus 1. Of course, the differential of c is 0, so I will not put it there na. So this will be 1/2 and 2 will cancel out. So we have your y dy. Your 2 here will also cancel out. So we'll have 5y dy all over y squared minus 1. And you can factor out dy. So this will be your y plus 5y over y squared minus 1 dy. Yan. So there, okay. You can combine the two, di ba? You have, this is understood na may over 1 dyan, and you have to combine the two, you have to get the LCD. So you will get y multiplied by y squared minus 1 plus 5y all over y squared minus 1 dy. Yan. This is dy. And simplifying further, this will be y cubed minus y plus 5y all over y squared minus 1 dy. And let us try to simplify pa. This will be y cubed, negative y plus 5y, that would be positive 4y all over y squared minus 1. Of course, yung dy. Yan. So this will be, this is the result, the differential of our answer. Let's try to check y cubed plus 4y all over y squared minus 1. Y cubed plus 4y all over y squared minus 1. Okay, so they are exactly the same, right? So this one right here, the result is actually exactly the same with the original given function. This one. The same siya doon, di ba? So the same. So therefore, indeed, our answer is correct. Y squared over 2 plus 5 over 2 ln of y squared minus 1 plus c. So that's your final answer. Yan. Okay, let's have one last example. Okay, so we have here the integral of, we have here dt over t ln t. Okay, so obviously, you cannot use the power formula there because the two factors, dalawa lang naman yung factors, di ba? Yung t at ln t. So the two factors is on the denominator, and therefore your value for n is equal to -1. So you cannot use the power formula. So we'll go directly to logarithmic function formula. But the question is, ano ba yung u natin? Okay, let's try. If our u is the whole denominator, t ln t, your du would be equal to t, derivative of ln t, that would be dt over t, right? Derivative of ln t plus ln t dt. Yeah, so this will cancel out. Then you will be left out with dt plus ln t dt. And if you factor out dt pa, you will have 1 plus ln t dt. Yeah, and obviously 1 plus ln t cannot be found on your original given function. So therefore, you cannot use t ln t as your u. How about if we try your u as ln t? So your du would be equal to derivative of t over t. And dt over t is right here. It can be found in your given function. So therefore, we can do that. So we have here the derivative of u equal to dt over t. So if we apply the left side of the formula of the logarithmic function formula, we have the integral of dt over t all over ln t. Yan. And applying okay, obviously this one is exactly the same with that one. Okay? So magpareho hira. So you can apply the right side of the formula, and that is ln of u, and your u is ln t. So ln of u, that would be ln of ln t. Of course, don't forget the plus c. Yeah, so this will be your final answer. ln of ln t plus c. Okay, let's try to check if indeed that's the right answer. So we'll get the differential of ln of ln t plus c. So this will be ln of ln t, that would be the differential of ln t over ln t. Differential of c is 0, so I will not put it there na. So this will be differential of ln t, that would be dt over t all over ln t. Simplifying further, you will get dt all over t ln t. And as you notice, this result is exactly the same with the original given function. Yeah, so therefore our answer is ln of ln t plus c. So this is correct. Okay, so that's how you solve using the logarithmic function formula for integration. Okay, so this formula can be applied if your n is equal to -1, provided, however, that the differential of your u can be found on the given function. Okay, so the next video will introduce the exponential function formula for integration. Yeah, so thank you for listening. I hope you learned something. And please subscribe to help me grow this channel. Thank you and have a nice day.